All right, for part B, they say the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence and show the work that leads to your answer. Okay, so in here, what I can do is the following. I can go ahead and take the general term from the from part A, and if we recall the general term, so I'll write that as the nth term is going to equal, we had negative 1/2 to the n times 1 over n times x minus 1 to the n. And I can go ahead and do a limit. Now there might be a faster way to try to determine, okay, if the radius of convergence is 2, it should converge probably from negative 1 up to 3, and then try to figure out stuff. I'm going to still do this process, even though it might be extra work. So we'll do the ratio test, so the limit as I get to larger and larger terms of the n plus first term over the nth term has to be less than 1. And what we get from there is the limit as n approaches infinity of, in the numerator we have negative 1/2 to the n plus 1 times 1 over n plus 1 times x minus 1 to the n plus 1. In the denominator, we have negative 1/2 to the n times 1 over n x minus 1 to the n. That has to be less than 1. And I can reduce this down a little bit, so limit as n approaches infinity. In here, if I work this out, I will have negative 1/2 to the n plus 1 over negative 1/2 to the n gives me a negative 1/2 in the numerator, which is the same thing as having a negative 2 in the denominator. 1 over n plus 1 and 1 over n, as we approach infinity and we sort of flip these around, this division is going to approach 1, so they, for all intents and purposes, sort of cancel. And in this, x minus 1 to the n plus 1 over x minus 1 to the n, there's one more x minus 1 up here, so we'll be left with one of those here. And notice we have no more n's, so the limit as n approaches infinity is just this. And I can multiply through and see that, okay, just as I was thinking, we end up with the absolute value of x minus 1 has to be less than 2. And that means that negative 2 is less than x minus 1 is less than positive 2. We add 1 to both sides. Negative 1 less than x less than 3. Definitely. Now we need to consider if any of these should be inclusive, whether this should be less than or equal to. So let's consider that. So at x equals negative 1, this here will be will end up having these terms being negative 1/2 to the n times 1 over n times, and this is going to end up being negative 2 to the n. And when I multiply this through, that's going to end up being 1 over n. And this is a harmonic series. Harmonic series do not converge, so we should not have less than or equal to here. Let's consider the next one. At x equals 3, so when I do this, we have negative 1/2 to the n times 1 over n times 2 to the n, which reduces down to negative 1 to the n times 1 over n. This is alternating harmonic. It does converge, so we do have that, or equal to. So this, just to sort of wrap it up, this right here, we get this 1 over n harmonic does not converge. We don't include negative 1. This, we get negative 1 to the n over n, which is alternating harmonic series. And that one does converge, so we include the or equal to here.